Today we're going to talk about the probability of independent events. Two events are independent if the occurrence of one has no effect on the other. So, like if I were to flip a coin 2 times, the first result, the first outcome, does not affect the second one. If I get a heads the first time, it doesn't mean the second one has to be a tails, so that way it's a 50% heads, 50% tails result altogether. It's just that each event does not affect the one following. So to calculate the probability of independent events, if A and B are independent events, the probability is the probability of A times the probability of event B. So in general, the probability that n independent events occur is the product of the probabilities of those individual events. So example 1, for a fundraiser, a class sells 150 raffle tickets for a mall gift certificate and 200 raffle tickets for a booklet of movie passes. You buy 5 raffle tickets for each prize. What is the probability that you win both prizes? So the probability that you win the mall gift certificate is 5 out of 150, and the probability of B that you get the movie pass is 5 out of 200 because you have 5 tickets out of 200 total. So the probability together of those is 5 over 150 times 5 over 200, and that's going to be 25 over, it's going to be a big number, and maybe we should have reduced the fractions ahead of time, but it's okay. 25 over 30,000, and that can be reduced to 1 out of 1,200. So we have a 1 out of 1,200 chance to win both prizes. Now, example 2, a spinner is divided into 10 equal regions, numbers 1 through 10. What is the probability that 3 consecutive spins result in a perfect square? So first we got to find the probability of a perfect square. I'm going to call it a square. So between the numbers 1 and 10, how many perfect squares do we have? We have 1, 4, and 9. So it's 3 out of 10 to land on a perfect square on any spin. Now it says what's the probability that 3 consecutive spins result on perfect squares. So the probability of 1 is 3 out of 10 times the probability of landing on it again, 3 out of 10. Probability of landing on it again is 3 out of 10. So 3 times 3 times 3 is 27 over, not 90. 10 times 10 times 10 is 1,000. So the probability of 3 spins in a row, all landing on perfect squares, is 27 out of 1,000. Now, example 3 is a little bit trickier. It says during each of the 5 days of Secretary Week, a secretary is randomly given 1 of 10 prizes. All prizes are available each day, and one of the prizes is a $500 gift certificate. What is the probability that the secretary receives the $500 prize at least once? So it's not saying that she will get it exactly 1 time or exactly 3 times. It says at least once, meaning she could win it just 1 time. She could win it all 5 days. She could win it 2 days. And it doesn't even have to be on certain days. She could win it on the 2nd day or the 4th day or the 5th day. So this is a pretty complicated problem and it has a lot of variables. So what we want to do is think about the complement and say, what is the probability that she doesn't win it at all? What is the probability that she does not get this prize? Well, she gets a prize every day, and one of those prizes is a $500 gift certificate. So the probability that she doesn't get a $500 gift certificate on a specific day is 9 out of 10. There are 10 prizes total. 9 of them are not the gift certificate. So the probability of not getting the gift certificate, no certificate, is equal to 9 out of 10. So let's find the probability that she never wins. She never gets the gift certificate. So she has a 9 out of 10 chance on each day to not get the gift certificate. So on the first day, she has a 9 out of 10 chance of not getting it. Second day, 9 out of 10. Third day, 9 out of 10. Fourth day, 9 out of 10. And on the fifth day, she also has a 9 out of 10 chance to not get that gift certificate. So if we type this into our calculator, 9 times 9 times 9 times 9 times 9, or 9 to the 5th power, we get 59,049 over 10 to the 5th power is 100,000. So she has a 59,049 out of 100,000 chance to not get the prize. So we could change it to a percentage or a decimal at this point, or we can wait until afterwards. So if that's the probability that she won't get the prize, the probability that she will get the prize of the $500 gift certificate is 1 minus that terribly ugly fraction. And again, we can rewrite this as 1 as 100,000 over 100,000 minus 59,049 over 10,000, or sorry, 100,000. And that will give us 40,951 over 10,000, or sorry, 100,000, which is about 40.95. Actually, let's write this as a decimal first. 0.4095, which is 40.9%. So she has a 40.9% of getting that gift certificate at least one time. And again, we don't know if she gets it 2, 3, or on the third day or the first day, but she does have a 40.9% chance of getting it at some point. So that's what makes the complement powerful. Trying to figure this out without it, there's a lot of possibilities that we'd have to address. All right, so example 4 says find the probability of drawing the given cards from a standard deck of 52 cards. You replace each card after you have drawn the card. So what that means is, like, if I wasn't replacing cards and I select a card and I don't put it back, well, now there are 51 cards left in the deck. And I take another away, don't put it back, there are 50 cards in the deck. So there become fewer and fewer cards in the deck. So by replacing them, we know that the denominator of each of these independent events is going to be 52. So the probability of an ace, then a 7, then a face card. So the probability of an ace is 4 out of 52 times the probability of a 7 is also 4 out of 52. So let's write that down. And the probability of a face card, well, we have 12 face cards. So we can multiply those fractions, and let me show you how we can multiply fractions in the calculator. So we literally just type in these fractions, 4 out of 52 times 4 out of 52 times 12 out of 52. And we get 3 over 2,197. And the nice thing is we don't have to worry about reducing the fractions if we use our calculator. All right, so then letter B, the probability of a red 2. So there are 2 red 2s, so 2 out of 52. The probability of pulling a red 2 again, 2 out of 52. And then a blue 2, or sorry, black 2, 2 out of 52. So if we type this in our calculator, we get this right here, 5.68957 e to the negative 5. So that means move the decimal to the left 5 times. So if I have 5.6 e to the negative 5, and I'm moving this to the left 5 times, 1, 2, 3, 4, 5, and then I have all of these zeros. So the probability is 0.00056 in decimals. And you can convert that to a percentage if you want, or leave it as that. I would leave it like that. All right, then letter C, probability of a heart. So there are 13 out of 52 hearts, or 1/4 if you want to do that. A black club. Well, all the clubs here are black in a deck. So it's going to be 13 out of 52 times 3, which is 4 out of 52. Because there are 4 3s. So if we type that into our calculator, and to make things easier, we can just go up and grab what we have up here and change this stuff. Okay, it was 4 out of 52, and then 13 out of 52, and this one was also a 13 out of 52. Hit enter, and we get 1 out of 208. So that's the chances of having that sequence, a heart, a black club, and then pulling a 3. So the idea of that, when we have independent events or and things, like if we want this and that to happen, we want an ace and then a 7 pulled, we multiply those individual probabilities to get the probability of the compound event. So that's it for the video. Thanks for watching. Make sure to like and subscribe.